The darkness between stars holds travelers we're only beginning to recognize. On a summer morning in 2025, automated sky surveys detected something entering our solar system from the cosmic void beyond. They designated it 3IATLAS, marking it as the third confirmed visitor from interstellar space humanity has ever recorded. What seemed at first like another icy wanderer, another frozen relic from alien stellar nurseries, would soon reveal characteristics that don't align with anything in our catalogs of natural objects. And then came the remote viewers, individuals trained in protocols designed to perceive distant targets through consciousness alone, methods developed during Cold War intelligence programs that remain controversial but documented. When these viewers turned their focus toward 3IATLAS, when they entered the sessions blind with only an alphanumeric designation and no conventional information about what they were observing, they reported something that should have been impossible. Not a comet, not a simple chunk of ice and rock tumbling through the void. They described metallic surfaces, biological elements fused with technological components, internal chambers packed with what one viewer estimated as millions of entities in some form of stasis or hibernation. Structures that suggested intelligence, purpose, design, spanning time frames that make human civilization look like a fleeting moment. These aren't fringe claims from untrained mystics. The remote viewing protocols used have documented success rates in military applications that kept programs funded for over 2 decades, despite mainstream science's dismissal. The viewers who examined 3IATLAS included individuals with years of training, verified track records in previous projects, working independently under blind conditions where contamination between sessions becomes statistically improbable. What they perceived converged in ways that pure chance or shared cultural expectations struggle to explain. They all described combinations of organic and artificial. Every single one. They used language like fuselage and hull alongside words like slimy and gel-like, as if perceiving something that doesn't fit our categories of life or machine, but exists somewhere between or beyond both. The scientific observations that followed their remote viewing sessions began revealing anomalies of their own, anomalies that, while explained through natural processes by some researchers, align disturbingly well with what the consciousness-based observers reported. Before the remote viewers ever mentioned internal structures or artificial construction, before they described aged metallic surfaces covered in strange emissions, instruments were detecting chemistry that doesn't belong in comets. Pure nickel without accompanying iron. Carbon dioxide ratios 8 times higher than water when it should be reversed. Activity occurring at distances from the sun where ice should remain frozen solid. Each observation explainable individually through exotic but natural circumstances, yet accumulating into patterns that resist simple categorization. Let your mind settle as we explore what multiple independent sources perceived and measured about this interstellar visitor. No rush toward conclusions, no forcing of interpretation, just the patient accumulation of observations that don't quite fit, testimonies that converge from different methodologies, data points that whisper possibilities our frameworks struggle to accommodate. By the time dawn breaks or sleep finally claims you, you'll understand why 3IATLAS has become more than astronomical curiosity. You'll understand why some researchers privately acknowledge that we might be witnessing something that changes everything about humanity's cosmic context, while others insist with equal conviction that we're simply seeing natural phenomena through the distorting lens of human pattern seeking. The remote viewing sessions began in August 2025, organized by a collective called Adventures in Remote Viewing. They assembled 6 experienced practitioners, each with documented backgrounds in perception-based intelligence gathering. The target was designated with the numerical code 77483-050, giving viewers no information about what they were supposed to perceive. No images, no descriptions, no context that could contaminate their sessions with conventional knowledge. The protocol demands this blindness, this complete informational isolation, ensuring that whatever emerges comes from the viewing process itself rather than from expectations or cultural assumptions about aliens and spacecraft. What emerged was remarkable, not because it proved anything definitive. Remote viewing doesn't meet scientific standards of reproducible evidence, but because of the convergence. Independent viewers working separately, sometimes in different time zones, never communicating about their sessions until after completion, produced overlapping descriptions that touched on specific technical details rather than vague generalities. They all perceived a 3-dimensional hollow structure with viewing chambers and observation windows. They all described electrical phenomena, buzzing sensations, static discharges, glowing elements scattered across surfaces. Several mentioned the object generating a spray of particles ahead of itself, pushing material forward and backward, which aligns eerily with speculation that interstellar craft might deploy precursor clouds to clear dangerous debris from their paths. One viewer, John Dixon, sketched images of what he perceived as manufactured rather than naturally formed, decorated with lime green and bright white light emanating from seams between hexagonal sections. He described how this white light transformed to green when exposed to what he interpreted as oxygen or heat, involving metallic layers that appeared to vaporize or sublimate. His drawings showed various metals arranged in distinct layers, possibly creating the unusual emissions that telescopes were independently detecting. The pure nickel with no iron, chemistry that violates expectations of natural mineral formations, suddenly had a potential context, not violation of cosmic chemistry, but perhaps evidence of layered construction using materials selected for specific purposes we don't yet understand. Another viewer in the group, Patricia, perceived crowded internal spaces suggesting high-tech technology beyond current human capabilities. She described sensing non-human consciousness with sophisticated communication abilities and what struck her as a dismissive attitude toward human intelligence. Multiple viewers independently reported this sensation of being observed back, of the object or whatever occupies it being aware of the remote viewing attempt, but largely uninterested, not hostile, not threatening, simply indifferent, the way humans might regard insects attempting to comprehend spacecraft. The psychological impact of this perception shouldn't be underestimated. These were experienced remote viewers accustomed to observing targets without emotional response. Yet they emerged from sessions describing an intelligence that acknowledged their presence with what felt like cosmic boredom. The work of Bertie Jaworski, under a different project with target designation 4952877, produced its own fascinating data. Her sessions focused on what she termed echo impressions, faint reverberating signals suggesting 3IATLAS might be a relic probe from a long-extinct Martian civilization. She and her team perceived holographic echoes of glowing crystalline structures on the object's surface, technologies that aren't invading but returning home. The phrase they kept using was homing beacon, as if 3IATLAS broadcasts signals designed to awaken dormant technology on Mars and possibly Europa, Jupiter's ice-covered moon, where subsurface oceans might harbor who knows what ancient installations or preserved systems waiting for the right signal to reactivate. This interpretation fits uncomfortably with scientific theories about panspermia, the hypothesis that life spreads through cosmos via natural or artificial seeding. If Mars once harbored advanced civilization, a controversial idea supported by some isotopic evidence we'll examine later, and if that civilization sent out probes before whatever catastrophe ended them, then an object returning now, after billions of years, might be attempting to reconnect with remnants. Not an invasion from foreign intelligence, but a homecoming. Not strangers, but distant relatives, checking on descendants of survivors or the ruins of what was lost. The emotional resonance of this narrative appeals to something deep in human psychology, our longing for connection with the past, but that doesn't necessarily make it wrong. Sometimes the story that feels right happens to be true, and sometimes our emotional responses point toward truths our rational minds resist acknowledging. The most unsettling testimony came from Sebastian Martin, a perception-based intelligence specialist who claims he was contacted by intelligence agencies, though he won't specify which, and asked to remotely view 3IATLAS. What he perceived shook him profoundly enough that he chose to speak publicly despite potential professional consequences. He described a massive mothership, kilometers in scale, packed with what he estimated as millions of dormant occupants. He used terms like reptilian and draconian, not as science fiction references, but as the closest descriptive language available for what he was perceiving. Beings in some form of suspended animation or low-energy state, waiting. Waiting for what? For arrival at destination? For specific conditions to be met? For signals from the planetary system they're approaching? Martin didn't claim to know, only to perceive the waiting itself as a palpable quality of whatever consciousness or automated systems maintain the object. But Martin's testimony didn't stop with the remote viewing. He claims a CERN insider, someone working at the European Organization for Nuclear Research, where the Large Hadron Collider smashes particles at near light speed, revealed something extraordinary. Scientists there allegedly activated a portal, not metaphorical or theoretical, but actual, using the particle accelerator to create or access a dimensional gateway for two-way communication with whatever is inside, or controlling 3IATLAS. The story goes that holographic figures appeared in the facility, tall beings described as reptilian or draconian in appearance, communicating telepathically with each scientist in the room simultaneously. Every person received the same message at the same moment. We come in peace. We are here to gather the star seeds of this planet. Now, this is where testimony ventures into territory that most scientists won't touch, and where our exploration must acknowledge the profound speculative nature of these claims. Starseeds, in New Age terminology, refers to souls or consciousness that originated elsewhere in cosmos, incarnated on Earth for specific purposes related to humanity's evolution or awakening. Whether you interpret this literally, metaphorically, or dismiss it entirely, the consistency of the message across multiple recipients is notable if the testimony is accurate. And the timing, if true, aligns with 3IATLAS's perihelion behind the Sun in late October 2025, the moment of closest approach and highest energy state, when such dimensional connection might require less power to maintain, or when the object's systems reach peak operational capacity. The CERN angle is particularly controversial because particle physics experiments do technically create conditions that didn't exist in our local space-time since moments after the Big Bang. High-energy collisions probe the fabric of reality in ways we don't fully understand. Theories about creating microscopic black holes, accessing extra dimensions predicted by string theory, or punching through quantum foam into whatever substrate underlies observable reality aren't entirely fringe. They're speculative extensions of accepted physics taken seriously by some theorists, though hotly debated by others. Whether any of that translates to opening portals for communication with interstellar objects requires leaps that most scientists won't make without extraordinary evidence. But then, most scientists also wouldn't have predicted that remote viewers would independently describe the same combination of biological and mechanical features with no prior information. Yet that convergence occurred according to documented session records. The Future Forecasting Group, another collective of remote viewers, conducted sessions on 3IATLAS that uncovered what they describe as bizarre correlations with apocalyptic timelines. They report viewing the object deploying swarms of smaller probes upon reaching perihelion, probes that trigger global plasma storms and EMP-like disruptions as they enter Earth's atmosphere or magnetosphere. These visions place the critical window around December 2025, right when 3IATLAS reemerges from behind the Sun and should be most visible from Earth after its closest solar approach. The forecasters describe a fork in the timeline, a divergence point where humanity either integrates benevolent extraterrestrial technology and experiences a leap forward in consciousness and capability, or enters what they call a dark forest-style conflict scenario, named after the science fiction concept where civilizations hide from each other because contact equals annihilation for the weaker party. The philosophical framework here requires unpacking. Remote viewing isn't supposed to work according to our current understanding of physics. Information can't travel faster than light. Consciousness can't observe distant objects without some physical interaction mediated by particles or waves. Perception requires sensory input from photons or other measurable phenomena, and yet under controlled conditions that multiple academic institutions and government agencies have studied. Remote viewers have located submarines, described buildings they've never seen, provided details about events before they occurred, with accuracy rates exceeding chance at statistically significant levels. The mechanisms remain unknown, unexplained by conventional physics, but the phenomenon has enough documented instances that dismissing it entirely requires ignoring a body of data that, while not meeting hard science standards, is statistically compelling enough to deserve serious investigation rather than reflexive dismissal. So, what do we make of the 3IATLAS remote viewing data? Several possibilities present themselves, none entirely satisfying, all requiring we hold uncertainty without forcing premature resolution. First possibility, it's all confabulation, imagination, filling blanks, pattern matching to existing science fiction tropes about alien motherships and ancient Martian civilizations. The viewers are picking up on cultural narratives floating through the collective unconscious, archetypal patterns that humans have been projecting onto mysteries since we first looked at stars and wondered what they might be. This explains convergence through shared mythology rather than shared perception of external reality, through contamination of ideas rather than observation of facts. Second possibility, the viewers are tapping into something real but misinterpreting it through the lens of human experience and expectation. They're perceiving energy signatures, structural features, perhaps even intentionality of some kind, but translating those perceptions into familiar metaphors. What registers as reptilian might be a specific frequency pattern or geometric configuration that human consciousness interprets through available biological templates. What feels like dismissive intelligence might be automated systems or artificial intelligence that doesn't recognize biological consciousness as particularly significant, operating on timescales and according to priorities that make human concerns seem trivial. The homing beacon interpretation might be correct in essence while wrong in specifics, an ancient probe returning home, but not from Mars, not from any civilization we'd recognize, from something older or stranger or more fundamentally alien than our categories allow. Third possibility, the remote viewers are accessing future timelines or probability clouds, quantum superpositions of what might happen, and describing the most likely or most energetically charged outcome. In this model, they're not seeing 3IATLAS as it is now, but as it might become, as it might act, as the situation might unfold depending on choices and chance yet to occur. The apocalyptic scenarios, the probe deployment, the plasma storms exist as potentials that may or may not manifest depending on countless variables still in flux. This interpretation draws on quantum mechanics, many worlds interpretation, or collapse theories, suggesting consciousness can interact with probability waves before they crystallize into definite outcomes, perceiving multiple futures simultaneously, until observation or decision forces reality to choose one path over others. Or, fourth possibility, the one that makes institutional scientists most uncomfortable. They're right. 3IATLAS is exactly what they describe. A biological, mechanical hybrid craft containing dormant beings from an ancient civilization, possibly Martian in origin, possibly something even older, using technologies that bridge dimensions or timelines in ways our physics hasn't yet discovered. Approaching Earth not by chance, but with purpose, with intent that involves contact, collection, or catalyst for transformation we can barely conceive. And that purpose involves what the CERN communication described as gathering star seeds, whatever that might actually mean beyond the New Age terminology used to convey it. The problem with evaluating remote viewing data is that it exists outside normal frameworks of verification. We can't run controlled experiments on one-time events like an interstellar object's passage through our solar system. We can't isolate variables or demand replication when the target itself is unique and transient. We can only compare what viewers reported to what happens, and even then, interpretation remains subjective. If 3IATLAS releases smaller objects in December, does that confirm the remote viewing, or is it natural process of cometary fragmentation? If unusual electromagnetic disturbances occur, plasma events, or communication attempts detected, do we have sensors in place to measure them accurately and will to acknowledge what they might mean? Or will natural explanations be constructed, however elaborate, to avoid accepting possibilities that threaten our comfortable assumptions about our place in an apparently empty universe? What strikes observers examining this data with as much objectivity as the subject allows is the specificity. Generic claims like, "there's an alien ship," are unfalsifiable and useless, offering no testable predictions. But claims about hexagonal seam patterns emitting specific colored light under certain conditions, about layered metallic compositions that vaporize in predictable ways, about internal viewing chambers and dismissive attitudes toward human intelligence, these are details that go beyond random guessing. They're testable in principle if we ever get close enough to 3IATLAS to verify them. If missions are approved to intercept or at least approach for detailed study, and the consistency across viewers who didn't collaborate, who worked under blind conditions, who came from different training backgrounds and methodologies, suggests they're perceiving something, even if what that something actually is remains open to interpretation that ranges from collective hallucination to accurate observation of reality. Our instruments haven't yet confirmed. One element that multiple remote viewing sessions emphasized was the sense of camouflage, that 3IATLAS is deliberately designed to appear natural, to mimic a comet or asteroid, to hide in plain sight among the countless rocks and ice balls that drift through interstellar space. This isn't paranoia projected onto ambiguous data, but strategic thinking. If you're an advanced civilization exploring potentially hostile territory, mapping stellar systems that might contain intelligent life, you don't announce yourself with flashing lights and radio broadcasts. You observe, you learn. You remain undetected until you've assessed the situation, determined whether the inhabitants pose threats or opportunities, whether contact would be welcomed or trigger defensive responses that complicate your mission. A probe disguised as a comet could enter a solar system, pass through unmolested by any primitive detection networks or defense systems, gather comprehensive data about planetary compositions and technological development levels, and depart without ever triggering alarm responses, if any exist. The scientific observations we have so far don't contradict this possibility. 3IATLAS has a coma, that cloud of gas and dust surrounding the nucleus that's characteristic of comets. It's shedding material as solar radiation heats its surface. It exhibits features that at first glance match cometary behavior, but it also lacks a traditional tail, despite approach angles that should produce one. It has impossible chemistry, pure nickel without iron, CO2 ratios inverted from what nature typically produces. It maintains trajectory despite mass loss that should alter its path through rocket-like thrust from outgassing. It follows a course suspiciously aligned with our planetary orbits. It looks enough like a comet to pass initial scrutiny from automated detection systems and casual observation. But weird enough when examined closely, when instruments probe its composition and trajectory, with precision measurements to raise flags among researchers who notice anomalies. Exactly what you'd expect from camouflage designed by intelligence that understands our observational capabilities. Good enough to fool cursory examination. Suspicious under detailed analysis that reveals inconsistencies natural objects wouldn't display. The question becomes whether those inconsistencies result from exotic but natural processes we simply haven't encountered before in our limited sample size of interstellar visitors, or whether they're signatures of artificial construction leaking through a disguise that can't quite hide every telltale sign of manufacture. Then there's the blocking phenomenon several viewers reported during their sessions. Some described their remote viewing being interfered with, as if something was aware of their attention and didn't want to be observed, actively resisting or deflecting their perception. Others reported getting through but sensing defenses or barriers, layers of shielding or misdirection that required effort to penetrate. One viewer, John Dixon, specifically mentioned that those inside, if there is an inside with occupants, seemed afraid of the outcome, perhaps relating to their plan. Afraid implies anticipation, consciousness aware of consequences, stakes attached to success or failure. Things don't plan if they're not intelligent. Things don't fear outcomes if they're not aware of multiple possible futures and the differences between them. The most mind-bending aspect of all this remote viewing testimony isn't whether it's accurate in describing external reality. It's what it implies, if even partially correct, about what we're confronting. We're not talking about a simple binary of comet or craft, natural or artificial. We're talking about a spectrum of possibilities where biology merges with technology in ways our categories can't cleanly separate, where ancient and advanced aren't contradictory but describe the same thing viewed from different temporal perspectives, where intelligence might not resemble anything in our experience, might operate according to principles we haven't discovered, serving purposes we can barely imagine across timescales that dwarf human civilization's entire existence. The remote viewers consistently described 3IATLAS as ancient, using words like artifact, relic, aged, weathered by unimaginable time in cosmic voids, but also high-tech, sophisticated, advanced, suggesting a civilization that achieved technological maturity millions or billions of years ago, then either transcended, collapsed, or dispersed, leaving behind probes that continue operating on missions defined so long ago their creators might not even exist anymore in any form we'd recognize. We're potentially looking at the universe's equivalent of a message in a bottle cast into cosmic ocean eons past, finally washing up on our shore. And we're arguing about whether the bottle is glass or plastic, instead of opening it to read what message might be inside, if any message survives, or if the bottle itself is the message. The December 2025 timeline appears repeatedly in remote viewing sessions as a critical juncture, a convergence point where something shifts. Whether that's because the viewers are genuinely perceiving a future event, because the target cue inadvertently included temporal markers that focused sessions on that period, or because December simply represents when 3-ATLAS becomes observable again from Earth after passing behind the Sun, and thus creates a natural focal point for predictions, remains unclear. But the convergence on that time frame, independent of astronomical calculations about visibility and perihelion, is worth noting. Multiple viewers, working independently, without coordination, arriving at the same general period for when something happens. If something is going to happen, if 3IATLAS is going to do something beyond just passing through our solar system on its hyperbolic trajectory back toward interstellar space, December is when we'll know. Until then, we're left with testimonies that read like science fiction, yet come from people with documented track records in perception-based intelligence work. We're left with descriptions that match uncomfortably with some of the anomalies scientific instruments are detecting, chemistry and behavior that don't quite fit natural models. And we're left with questions about consciousness, about what human perception can access beyond the 5 physical senses evolution gave us, about whether the universe is stranger and more connected than our materialist models allow, whether information can flow through channels we haven't discovered or can't measure with current instruments. 3IATLAS, viewed through the lens of remote perception, isn't just an object moving through space following physics. It's a mirror reflecting back our assumptions about what's possible, our fears about what might be watching us, our hopes that we're not alone in a vast, indifferent cosmos, and possibly our origins in ways we're not ready to accept. The scientific method demands we not accept extraordinary claims without extraordinary evidence. Remote viewing doesn't provide that evidence in forms that satisfy rigorous empirical standards, but it does provide data points, observations from a different methodology, testimonies converging in ways that pure fabrication or chance struggle to explain. And when those testimonies align even partially with instrumental measurements detecting chemistry that shouldn't exist, and trajectories that defy probability, dismissal becomes premature. Perhaps the most valuable contribution of the remote viewing sessions isn't what they claim to reveal about 3IATLAS itself, but what they reveal about the limitations of our current frameworks for understanding reality. We've built sophisticated technologies for measuring physical phenomena, instruments that can detect individual photons or gravitational waves from black holes colliding billions of light years away. But consciousness remains a mystery. How subjective experience arises from neural processes, how information integrates into unified awareness, how some people seem to perceive things they shouldn't be able to perceive according to our models of how senses work. These are open questions that mainstream science has barely begun addressing seriously. If remote viewing works at all, even occasionally, even with accuracy rates only slightly above chance, but consistently above what randomness would produce, then something is happening that our physics doesn't account for. Either consciousness can interact with reality in ways we don't understand, or information can flow through channels we haven't discovered, or time and causality work differently than we think at quantum scales, where observation and observer aren't clearly separable. The implications extend far beyond whether one particular interstellar object is natural or artificial. They touch on the fundamental nature of reality, mind, and the relationship between them. So as you drift toward sleep or continue listening through the night, consider that 3IATLAS might be important not because of what it is, but because of what our varied responses to it reveal about humanity at this moment in our development. We have some observers using telescopes and spectrometers, gathering data through instruments that extend our senses into wavelengths and scales we can't perceive directly. We have other observers using consciousness itself as instrument, attempting to perceive directly what instruments can only measure indirectly. Both groups are reporting anomalies. Both groups are describing something that doesn't fit expected patterns. Whether those anomalies and patterns indicate natural rarity or artificial presence remains contested. But the fact that multiple methodologies are converging on similar conclusions, that something about this visitor troubles our categories and resists easy explanation, that seems undeniable. The Mars connection deserves deeper examination because it provides a physical anchor point for what might otherwise remain pure speculation. On October 3rd, 2025, while most of Earth went about its daily routines unaware, something remarkable occurred approximately 18 million miles away in the cold void between planets. 3IATLAS made its closest approach to Mars, passing the red planet at a distance that in cosmic terms represents barely a whisper, closer than it would ever come to Earth, closer than any previous confirmed interstellar visitor had approached any planet in our solar system during our observation period. The timing, the geometry, the precision of that encounter raises questions that comfortable answers struggle to address. Why Mars? Of all the planets 3IATLAS could have aligned with during its trajectory through our solar system, why did its path carry it so close to the one world where we have the most evidence of ancient habitability, where rovers have discovered dried river valleys and lake beds, where minerals requiring liquid water for formation have been identified in multiple locations, where methane plumes still erupt periodically from unknown sources that might be geological or might be something else entirely. Random chance seems increasingly unlikely when you examine the orbital mechanics and probabilities. This wasn't just passing near Mars, but threading a needle through space with precision that suggests either extraordinary coincidence or deliberate navigation. Dr. John Brandenburg, a plasma physicist who worked on strategic defense initiatives, and has spent decades studying Martian geology through available data, has proposed something that mainstream planetary science rejects but can't entirely disprove through existing evidence. He suggests Mars didn't just lose its atmosphere through slow solar wind erosion over billions of years, as standard models claim. He suggests it was destroyed deliberately through thermonuclear explosions, not impacts from asteroids or comets following natural trajectories, but detonations that were weapons in conflicts we can barely imagine. The kind of explosions that leave specific isotopic signatures we can still detect in Martian soil samples and atmospheric measurements conducted by multiple missions. The evidence Brandenburg points to includes elevated levels of certain isotopes, particularly xenon-129, which forms during nuclear fission processes. The ratios don't match what you'd expect from natural radioactive decay operating over billions of years, or from cosmic ray bombardment, which creates different isotopic patterns. They match disturbingly closely what scientists see in terrestrial nuclear test sites, the signature of fission reactions releasing enormous energy in short time frames. He's also identified two regions on Mars, Cydonia Mensae and Galaxious Chaos, where concentrations of these anomalous isotopes are particularly high, concentrated in ways that suggest specific detonation points, ground zeros for massive explosions whose energy would dwarf anything humanity has produced. Now, before dismissing this as fringe speculation unworthy of serious consideration, let's examine what we know with reasonable certainty about Mars's history. The planet did have a magnetic field that shut down relatively suddenly in geological terms around 4 billion years ago. Without that protective magnetic field, solar wind could strip atmosphere gradually over time. Standard models attribute atmospheric loss entirely to this slow erosion process. But the isotopic anomalies Brandenburg identified don't align cleanly with gradual erosion timescales. They suggest catastrophic events, sudden releases of energy that changed atmospheric composition in ways gradual processes wouldn't produce. Multiple researchers have noted that the ratio of atmospheric argon on Mars is anomalous compared to models of planetary formation and evolution, suggesting something happened that wasn't just slow, steady loss, but involved discrete, energetic events. Which brings us to the really uncomfortable question that keeps some researchers awake at night. If Mars once hosted intelligent life, and if that civilization was advanced enough to either trigger or be targeted by nuclear destruction on planetary scales, what happened to them? Did they escape, fleeing to other worlds before the catastrophe consumed their civilization? Did they seed Earth with life before the end, making us their descendants carrying genetic heritage from a destroyed world? Or did they launch probes, vessels, arcs into the cosmos billions of years ago, hoping that someday their legacy would return to a restored Mars, or at least bear witness to what became of the world that birthed them? These aren't idle science fiction musings, but logical extrapolations from the hypothesis that Mars once hosted technological civilization, if that hypothesis has any merit. Cliff High, a data mining analyst who develops predictive models from language patterns across internet communications, has proposed exactly this scenario in his public presentations. He suggests humans are Martian descendants, that we're refugees or remnants of a civilization that either destroyed itself through warfare or was destroyed by external forces we don't yet understand, and that 3IATLAS is coming to communicate with its own civilization's surviving remnants. In this model, the object isn't alien in the sense of completely foreign intelligence from distant stars. It's homecoming, recognition, an ancient relative returning after eons to check on the children of survivors who rebuilt slowly on a neighboring world after catastrophe made Mars uninhabitable. The trajectory supports this interpretation to an eerie degree that makes coincidence increasingly difficult to defend. 3I Atlas's perihelion, its closest approach to the Sun, occurs on October 29, 2005, at approximately 1.4 astronomical units, positioning it just inside Mars's orbital distance. From Earth's perspective during this period, the object sits behind the Sun, rendering it invisible during its most active and energetically intense phase, when solar heating should drive maximum outgassing if this were a natural comet. But from Mars, the geometry differs dramatically. From Mars, 3I Atlas would be visible, observable, a bright object crossing the Martian sky precisely at the moment of peak activity when any signals or deployments would be most energetic. If you wanted to communicate with Mars, if you wanted Martian instruments or any surviving installations to detect your presence, this is exactly the trajectory you'd choose. The spacecraft we have orbiting Mars represent humanity's most capable off-world observation platforms. ESA's Mars Express and ExoMars Trace Gas Orbiter, plus NASA's Mars Reconnaissance Orbiter and rovers on the surface, all had perfect opportunity to observe 3I Atlas during its closest approach. What they captured, or more precisely, what images have and haven't been released to public scrutiny, has ignited speculation that no amount of official silence can extinguish. The European Space Agency released exactly one animation from their ExoMars Trace Gas Orbiter over a week after observations occurred, showing the object moving against background stars. Analysts noted that 3I Atlas exhibited more variation in brightness and apparent structure than those background stars, suggesting real changes, real complexity beyond what a simple tumbling ice ball should display. NASA's Perseverance rover, which carries cameras capable of night sky observation from Martian surface, captured something during this period that amateur astronomers later processed and enhanced from raw data uploads. The images show a smudge, a streak, faint light in the Martian night that appears in multiple frames at positions consistent with 3IATLAS's calculated trajectory. The object appears elongated in these images, almost cylindrical, though whether that elongation represents actual structure or motion blur during exposure time remains debated. Avi Loeb and others have offered natural explanations about exposure duration creating apparent length. But the fact remains, we're seeing something in the Martian sky at exactly the moment 3I Atlas was making its closest approach, and that something has characteristics requiring explanation. What we don't have troubles researchers as much as what we do. The Mars Reconnaissance Orbiter carries HiRISE, the highest resolution camera humanity has ever sent to another planet, capable of resolving features down to 30 centimeters on Martian surface from orbit. Turned skyward toward 3I Atlas, it should have captured images at 30 kilometers per pixel resolution, enough to reveal nuclear structure, surface features, potentially even evidence of artificial construction if such exists. Those images either don't exist, which raises questions about why such an obvious observation wasn't successfully executed during a once-in-lifetime opportunity, or they do exist and haven't been released, which raises different questions about what they might show that requires careful handling or indefinite withholding. The government shutdown that began October 1st, furloughing 15,000 NASA employees, meant the agency's communication offices went dark at precisely the moment when Mars observations of 3I Atlas should have been generating headlines and scientific papers. ESA released one blurry animation days after the flyby. NASA released nothing official from their Mars assets. The Chinese Tianwen-1 orbiter was perfectly positioned with clear sight lines. The UAE's Hope probe had an ideal observation angle. Even India's Mars orbiter MISTS Sion, still functioning years past its planned lifetime, could have contributed valuable data. Yet none of these agencies have released comprehensive images or statements about what their instruments recorded during this historic encounter. The silence is coordinated, deliberate, extending across 4 different national space agencies with different funding structures and political contexts, but apparently similar conclusions about what should and shouldn't be shared publicly at this time. Meanwhile, leaked information has begun surfacing through encrypted messaging platforms and anonymous image boards, digital spaces where whistleblowers and insiders can share material without immediate attribution. A user claiming contractor status at JPL, NASA's Jet Propulsion Laboratory, posted what they alleged were unprocessed HiRISE images of 3I Atlas before their account was deleted within hours and the images scrubbed from servers. The images, if genuine, and several independent analysts suggest they show characteristics consistent with legitimate HiRISE data rather than fabrications, depict an object that defies conventional explanation. It appears to have distinct sections, possibly separate modules, connected by a central framework or spine. There are what look like symmetrical protrusions that could be solar panels gathering energy, radiators dissipating heat, or sensor arrays monitoring surroundings. The image quality is poor, compressed, and degraded, possibly deliberately, but the implications stagger anyone who examines them carefully. The spectroscopic data that has been released publicly raises more questions than it answers, providing information while withholding context that would allow full interpretation. Mars Express detected unusual absorption lines that don't match typical cometary emissions cataloged from decades of observing solar system comets. The NOMAD spectrometer on ExoMars Trace Gas Orbiter found traces of complex organic molecules, but not the simple chains you'd expect from primordial ice preserving ancient chemistry from stellar nebulae. Instead, there are signatures suggesting processed materials, possibly even polymers, long-chain molecules with repeating structures that nature can produce under specific conditions, but which also characterize manufactured materials designed for particular properties. The teams analyzing this spectroscopic data have been remarkably circumspect in their interpretations, using careful language that avoids definitive conclusions while acknowledging anomalies. This caution is appropriate given the extraordinary implications, but it also creates information void where speculation flourishes. When scientists won't or can't say clearly what they're seeing, when preliminary findings get classified or embargoed pending further verification, the public and amateur research community fill gaps with theories ranging from prosaic to paranoid. Some of that speculation is wild and baseless. Some of it, uncomfortably, might be closer to truth than official narratives will acknowledge until forced by overwhelming evidence or external disclosure. Here's what makes the Mars encounter particularly significant from strategic perspective. 3IATLAS approached the red planet on a trajectory that seemed deliberately calculated for maximum observational opportunity, not from our instruments, but for the object to observe Mars. It passed through the orbital planes of multiple spacecraft, remaining visible to various instruments for extended period, measured in days rather than hours. If you wanted to be seen, to be studied by whatever detection systems exist around Mars, this is exactly how you'd approach. Yet, if you wanted to reveal yourself gradually, controlling the flow of information and rate of disclosure, you'd ensure that the most detailed observations happened when primary space agencies were conveniently unable to communicate findings due to bureaucratic disruptions, giving time for assessment and decision-making about what should be shared and what should remain restricted. The behavioral anomalies during the Mars approach add another layer to this deepening mystery. 3IATLAS showed what appeared to be course corrections visible in tracking data, tiny adjustments to its trajectory that kept it centered in observation windows of multiple spacecraft, despite the complex gravitational environment and solar radiation pressure that should introduce random perturbations. These changes were subtle, barely detectable, even with precision measurements, but they're there in the astrometry data that careful analysts have examined. Natural comets don't make course corrections. They follow ballistic trajectories modified only by gravitational forces from massive bodies and outgassing thrust from sublimating ices that should be random or at least chaotic rather than precisely targeted. 3IATLAS did something else, something that requires either active control or physical mechanisms. We don't understand operating according to principles our models haven't incorporated. Private aerospace companies have been notably absent from public discussion about 3IATLAS, despite having deep space tracking capabilities that in some cases rival or exceed government assets. SpaceX, with its global Starlink satellite network and deep space communication systems, Blue Origin, with its developing infrastructure, and other commercial space entities have maintained complete radio silence about this interstellar visitor. Industry insiders suggest there have been closed-door meetings, non-disclosure agreements signed with unusual urgency, and possible coordination with government agencies across national boundaries. The commercial space sector seems to know something the public doesn't, and contractual or legal obligations, or perhaps simple strategic calculation, keeps them from speaking. Social media has exploded with theories about what the Mars missions really saw during those critical October days. Hashtags related to 3IATLAS truth-seeking have trended globally multiple times, briefly before algorithms adjust and push the content down in visibility. Amateur investigators have noticed suspicious activity at deep space communication facilities, unusual aircraft movements around aerospace contractors, emergency sessions of space agency advisory boards convened with minimal notice. The pattern suggests coordinated response to information deemed too sensitive for immediate public release, a crisis management posture rather than normal scientific process of observation, analysis, publication, and peer review. The strangest report, one that's impossible to verify, but equally impossible to completely dismiss given the source's apparent technical knowledge, comes from an amateur radio operator in Australia who claims to have detected encoded transmissions from the direction of Mars during the flyby period. The signals used frequency allocations reserved for deep space missions, but didn't match any known spacecraft protocols in publicly available documentation. The operator recorded several minutes of transmission before the signal abruptly ceased, as if someone realized they were broadcasting in ways that shouldn't be detectable by civilian equipment, and shut down. Analysis of the recording shows structured data packets with mathematical regularities that suggest artificial origin rather than natural radio emissions from astronomical sources. But without decryption keys or context, the content remains mysterious, perhaps meaningless interference, or perhaps the most significant evidence yet that 3IATLAS is communicating with something, either Earth-based receivers or installations on Mars itself. The chemical enigma that 3IATLAS presents doesn't resolve when you examine it from Mars's perspective or Earth's. The water pouring from this object shouldn't exist at the rates and distances observed, not according to our models of how cometary ices sublimate under solar radiation. 40 kilograms per second, streaming into space like a fire hose at full pressure, while the object cruises through regions where water ice should be inert as stone, frozen solid without any activity beyond perhaps the most sluggish sublimation of hypervolatile compounds. The swift observatory's detection of hydroxyl radicals, the chemical fingerprint left when water molecules break apart in space, has given us our first solid chemical signature of this visitor. And what it reveals challenges fundamental assumptions about cometary physics that decades of observations had seemed to confirm. When water molecules fragment in the vacuum of space under ultraviolet radiation, they create hydroxyl radicals that glow in specific wavelengths detectable by specialized instruments. It's a process observed in countless comets, a reliable signature that lets astronomers measure water production rates from vast distances. But never like this, never with this intensity at this distance from the Sun. 3IATLAS was producing these hydroxyl signatures while nearly 3 astronomical units from our star, in the frozen depths where even carbon dioxide, which sublimates at lower temperatures than water, struggles to become active in natural comets. The energy required to drive this water production has to come from somewhere, and solar radiation at that distance can't account for more than a fraction of what's needed. The isotope ratios tell an even stranger story that makes some chemists quietly uncomfortable. The deuterium to hydrogen ratio in 3IATLAS's water doesn't match any reservoir in our solar system according to preliminary analysis. Not Earth's oceans, not Jupiter's icy moons, not the water ice in other comets that have been studied spectroscopically. This is alien water in the truest sense, formed around a different star under different conditions billions of years ago, carrying chemical signatures of environments we've never sampled. But here's the truly puzzling part that some researchers whisper about in private conversations. The ratios are too perfect, too consistent across multiple measurements, as if the water has been processed, purified, standardized in ways that nature, with its tendency toward chaos and variation, rarely achieves without special circumstances. Dr. Zexi Xing's team at Olin University has proposed that the water might be coming from floating ice grains in the coma rather than directly from the nucleus surface. These grains, somehow liberated from the main body through mechanisms not yet understood, would sublimate more efficiently due to their high surface area to volume ratio, explaining the vigorous water production at impossible distances. But this explanation raises its own questions that careful examination doesn't easily answer. How did the grains separate from the nucleus in the first place? What forces overcame the weak but real cohesion that should hold cometary material together? Why don't we see similar behavior in other comets at comparable distances where conditions should be essentially identical? And why do the grains appear to be uniformly sized according to scattering models, as if manufactured to specifications, rather than randomly broken apart by thermal stress or impacts? The nickel mystery deepens with each spectroscopic observation that astronomers conduct. Analysis shows strong nickel emissions without the accompanying iron you'd expect from natural differentiation processes that occur during planetary formation or asteroid evolution. The nickel to iron ratio is wrong by orders of magnitude, inverted from what centuries of meteoritics and planetary science have established as normal for undifferentiated bodies, or even highly processed materials from differentiated planetesimals. Some researchers have quietly noted in private communications, though rarely in published papers, where peer review would demand more caution, that this signature resembles certain industrial alloys more than primordial solar system materials. Nickel alloys specifically designed for extreme environments where corrosion resistance and structural integrity matter across immense timescales. Alloys that could theoretically survive billions of years in interstellar space without degrading significantly, maintaining their properties through temperature cycling and radiation exposure that would destroy most natural minerals. Carbon dioxide detection by the Sphere-X infrared observatory added another piece to this chemical puzzle that refuses to fit together cleanly. The CO2 emissions show unusual isotopic enrichment in carbon-13, a heavier variant that's relatively rare in our solar system compared to the more common carbon-12. This enrichment pattern could result from several processes. Biological metabolism often fractionates isotopes, preferentially using lighter variants and leaving residues enriched in heavier ones. Industrial refinement processes can produce similar patterns when materials are processed for specific purposes. Or formation in a stellar environment with different nucleosynthetic history, a star with different mass or age or metallicity than our Sun, could create primordial enrichments that natural solar system objects wouldn't display. Each possibility carries profound implications for the nature and origin of 3IATLAS, and distinguishing between them requires more detailed analysis than current observations provide. Think about the chemistry required to sustain water production at observed rates for weeks or months as 3IATLAS continues its journey. If the hydroxyl emissions are real and multiple independent observations from different instruments and research teams confirm they are, then the object must contain either vast reservoirs of easily sublimated ice positioned near the surface in ways standard comet models don't predict, or an internal heat source actively driving the sublimation process. The nuclear reactor hypothesis that sounds like science fiction suddenly seems less fantastic when you seriously consider the energy budget required and compare it to known power sources. A small fission or fusion reactor operating at modest power levels could easily generate enough waste heat to drive observed water production rates, venting coolant or intentionally sublimating ice for propulsion or thermal management. The organic molecules detected but not fully characterized in public reports present another enigma wrapped in institutional caution. The teams analyzing spectroscopic data have been remarkably coy about specifics, mentioning only complex chains and unexpected structures without providing the detailed breakdowns that normally accompany astronomical discoveries. Leaked spectra that briefly appeared on public servers before being removed suggest the presence of amino acids, the building blocks of proteins and life as we know it. But not the simple ones like glycine that we've found in meteorites and other comets, confirming that basic prebiotic chemistry is common in space. These appear to be more complex amino acids, possibly even showing chirality, the molecular handedness that's a hallmark of biological processes on Earth, where life exclusively uses left-handed amino acids, despite both mirror forms being chemically equivalent. Gas phase chromatography data from one of the Mars orbiters, briefly visible on a mission database before access was restricted, showed peaks consistent with long-chain hydrocarbons, according to independent analysts who captured screenshots before the data disappeared. Not the random mixture of hydrocarbon lengths you'd expect from primordial ice preserving ancient chemistry, but specific compounds with regular spacing in their mass spectrum, patterns that look suspiciously like someone has been performing chemistry rather than nature randomly creating molecules. Long chains of carbon and hydrogen atoms arranged with regularities that suggest selection, synthesis, purpose behind their presence, rather than mere accumulation from interstellar molecular clouds. The dust composition adds yet another layer to this chemical mystery that refuses to resolve into comfortable explanations. Unlike typical comets that release silicate dust, similar in composition to asteroids and primitive solar system materials, 3IATLAS's dust shows unusual spectral features when observed in infrared wavelengths. There are absorption bands that don't match known minerals in our spectroscopic databases, compiled from decades of studying meteorites and astronomical objects. There are emission lines that suggest exotic materials or perhaps, more disturbingly, manufactured particles engineered at the nanoscale for properties we don't yet understand. Some researchers have privately speculated about the possibility of smart dust, microscopic particles with embedded sensing or communication capabilities, though this ventures into territory where speculation outpaces evidence substantially. Temperature measurements from infrared observations conducted by multiple ground-based telescopes don't match thermal models that predict how objects should heat and cool at various distances from the sun. 3IATLAS appears warmer than it should be at its current location, not dramatically so, but consistently, measurably warmer by tens of degrees across multiple observations. This excess temperature suggests internal heat generation beyond what sunlight can provide at that distance. The temperature distribution across the object isn't uniform either, according to the highest resolution thermal imaging available. There are hot spots, regions consistently warmer than surroundings, that persist across multiple observations, maintaining their positions relative to the object's rotation. Natural comets don't have permanent hotspots that rotate with the body. Random outgassing creates temporary thermal anomalies that appear and disappear chaotically. But machines with power sources, with systems that generate heat during operation, those would produce exactly the kind of persistent localized warming that observations detect. The chemical evolution as 3IATLAS approaches the Sun and then recedes will be critically important for testing hypotheses. Natural comets show predictable changes in their emissions as different ices reach sublimation temperatures at specific solar distances. Water becomes active first as you approach the Sun, then carbon dioxide, then carbon monoxide, then finally the hypervolatiles like nitrogen and methane at closest approaches. If 3IATLAS follows this natural progression, its chemical signatures changing predictably with solar distance, that strengthens interpretation as exotic but natural comet. But if it continues its anomalous behavior, if chemistry remains inconsistent with thermal models, if emissions don't follow expected patterns, then we're observing something else entirely, something that doesn't operate according to rules that govern frozen ice balls drifting through space. Laboratory attempts to recreate 3IATLAS's spectral signatures have failed repeatedly, according to researchers who've tried. No combination of known ices and minerals in proportions that seem plausible produces the exact emission patterns observers are recording. Scientists have tried exotic mixtures inspired by theoretical models of interstellar ice formation. They've simulated primordial compositions from before our solar system formed, when the galaxy had different chemical abundances. They've even attempted to replicate processing that billions of years of cosmic ray bombardment might produce. Nothing matches perfectly. There are always discrepancies, spectral features that appear in observations, but not in laboratory simulations, or vice versa. It's as if 3IATLAS is made of materials that don't exist in our solar system, at least not in the combinations and proportions we're observing, or that its surface has been modified by processes we don't understand and can't reproduce in terrestrial laboratories. This chemical impossibility, if that's what it truly represents, rather than simply gaps in our understanding, forces consideration of artificial origin more seriously than institutional science is comfortable addressing publicly. If the materials aren't natural, if they've been refined or synthesized or processed in ways that create signatures we can't replicate from natural starting points, Then we're looking at manufacturing, at industry operating on scales and time frames that dwarf human capabilities but following principles that might not be entirely alien to us. The nickel without iron could be intentional materials selection. The isotopically enriched carbon dioxide could be refined propellant or coolant. The complex organic molecules could be lubricants, sealants, or even preserved biological materials from whatever created this object billions of years ago. As you continue listening, as sleep approaches or the hours of night stretch onward, let these chemical mysteries settle into your consciousness without forcing resolution. The data is ambiguous, capable of supporting multiple interpretations depending on which evidence you weight most heavily and which assumptions you're willing to question. Some researchers see an exotic but natural object, a comet from another stellar system, with chemistry that reflects different formation conditions and billions of years of processing by cosmic rays and interstellar radiation. Others see fingerprints of manufacture, signatures that nature wouldn't produce without help, evidence of technologies operating according to principles we partially understand but haven't mastered. Both interpretations fit some of the data. Neither fits all of it comfortably. And that ambiguity, that resistance to clean categorization, might be the most important information 3IATLAS is providing. Reality doesn't always conform to our categories. Sometimes the universe presents us with phenomena that exist in spaces between what we thought were discrete possibilities. The trajectory prophecy that emerges from careful analysis of 3IATLAS's path through our solar system reads less like random chance and more like a carefully orchestrated flight plan encoded in gravitational mechanics. Every calculation, every probability assessment, every statistical analysis points toward the same uncomfortable conclusion that some researchers voice privately, while others avoid entirely. This trajectory is too perfect, too precisely aligned with planetary positions, too optimized for gravitational assists to result from natural ejection from some distant stellar system, followed by billions of years of ballistic coasting through interstellar space. We're looking at odds that make winning major lotteries seem probable by comparison. Coincidences stacked on coincidences until the cumulative probability of everything happening naturally approaches impossibility. Begin with the approach vector that brought 3IATLAS into our cosmic neighborhood. The object entered our solar system on a retrograde orbit inclined at 175 degrees, essentially flying upside down and backward relative to the direction all our planets orbit the Sun. This retrograde geometry should have made planetary encounters less likely statistically, reducing the probability of close approaches by introducing misalignment between the visitor's path and the plane where planets congregate. Yet its path has threaded through our solar system with precision that defies expectation, passing close to Mars with exquisite timing, approaching Venus at favorable geometry, heading for Jupiter with trajectory that suggests each encounter was calculated rather than accidental, all while maintaining alignment with Earth's orbital plane, the ecliptic, to within 5 degrees of arc. Richard Clue's calculations revealed something that makes statisticians deeply uncomfortable. The timing of 3IATLAS's arrival synchronized with planetary positions in ways that probability theory struggles to accommodate through chance alone. Mars was perfectly placed for the October 3rd flyby, positioned in its orbit such that close approach became possible. Earth will be ideally positioned for the December encounter when the object reemerges from behind the Sun. Jupiter awaits its turn in March 2026 at orbital location that enables close observation. The combined probability of these alignments occurring naturally, according to rigorous statistical analysis that accounts for orbital mechanics and arrival vectors from interstellar space, is approximately 0 to 0.05%. That's 0.5 chances in 100,000, odds so remote that invoking them as explanation requires extraordinary faith in unlikely coincidence. Now, factor in the lack of non-gravitational acceleration despite massive outgassing that should create rocket-like thrust. Despite losing 40 kilograms of water per second, according to observations, despite releasing this material preferentially from specific regions that should create asymmetric forces, 3IATLAS hasn't deviated from its calculated path by even the tiny amounts precision astrometry can measure. This indicates either a mass so enormous that the rocket effect of sublimating gases becomes negligible, unable to budge something weighing tens of billions of tons, or active station keeping that detects and corrects for any deviation before it accumulates into observable trajectory changes. Either explanation challenges comfortable understanding of what we're observing. If it's mass, we're seeing something far denser or larger than appearance suggests. If it's station keeping, we're seeing artificial control systems operating with precision and responding to perturbations in real time. The ecliptic alignment becomes even more suspicious when you consider galactic geometry and the distribution of stellar velocities. Earth's orbital plane sits at approximately 60-degree angle to the galactic disk where most interstellar objects should originate, ejected from stellar systems scattered throughout the galaxy's spiral arms. For 3IATLAS to arrive aligned within 5 degrees of our ecliptic after traveling for potentially billions of years, covering distances measured in light years, while the galaxy rotated multiple times and stellar positions shifted, requires either extraordinary luck that probability calculations suggest we shouldn't expect to see even once in comprehensive surveys of thousands of interstellar visitors, or deliberate navigation that targeted our planetary system with specific approach geometry, calculated to optimize some objective we can only guess at. Consider the retrograde advantage from a tactical or strategic perspective. If this object represents a probe designed for reconnaissance or first contact, a spacecraft entering our solar system retrograde gains several benefits that engineers planning interstellar missions would recognize. Encounters with planets happen at higher relative velocities because you're moving opposite to their orbital motion rather than with it, making interception by primitive civilizations using chemical rockets more difficult, if not impossible, given the delta of requirements. The opposing motion allows for easier deployment of smaller probes that need to shed velocity to enter planetary orbits, using the mothership's retrograde momentum to efficiently place instruments or landing craft exactly where mission planners want them. The approach angle provides better observation geometry for studying multiple planets in sequence, allowing a single trajectory to gather data from Mars, Earth, Venus, and Jupiter, without requiring propulsion systems to bend the path significantly. This is exactly how you'd plan a reconnaissance mission if you wanted to survey an entire planetary system efficiently, gathering maximum information while minimizing propulsion requirements and detection risks. The trajectory isn't optimized for dramatic close approaches that would provide spectacular images but might seem threatening. It's optimized for comprehensive study at moderate distances that allow extended observation periods without triggering defensive responses from whatever intelligence might inhabit the system. It's a surveyor's trajectory, a cartographer's path, designed by minds or algorithms that understand orbital mechanics and the psychology of contact with potentially hostile, primitive civilizations that might shoot first and ask questions, never, if sufficiently, alarmed. The perihelion distance of 1.36 astronomical units places 3IATLAS at the perfect position for a solar Oberth maneuver if you're familiar with orbital mechanics terms, or more simply, for using the sun's gravity to change velocity with maximum efficiency. Too close to the sun and solar radiation might damage sensitive equipment, overwhelming thermal management systems designed for deep space operation. Too far and the gravitational assist becomes less effective, providing smaller velocity changes for the same propulsion expenditure. This precise distance allows maximum velocity modification with minimum thermal stress, ideal for either escaping the solar system at higher speed than arrival velocity or deploying objects into the inner system that can reach planetary destinations with minimal additional propulsion. The optimization is too perfect to casually dismiss, too precisely balanced between competing constraints to attribute to random ejection from some distant dying star system billions of years ago. Trajectory analysis reveals micro-corrections that careful examination of astrometric data suggests are real rather than measurement artifacts. Tiny changes in velocity and direction that occurred at specific points along the path through our solar system. Adjustments measured in meters per second rather than kilometers, barely detectable even with precision tracking. from multiple observatories. These corrections kept 3IATLAS centered in observation windows, maintained alignment with upcoming planetary encounters, compensated for gravitational perturbations from asteroids and the complex multi-body dynamics of the inner solar system. Natural forces operating on passive objects can't explain these adjustments with satisfying completeness. Outgassing thrust is too random, producing chaotic rather than targeted velocity changes. Gravitational perturbations are too well understood, too precisely calculable to account for discrepancies between predicted and observed positions. Something else is happening, something that requires either physics we don't understand or control systems we're not acknowledging. The future path holds even more intrigue for those tracking this visitor's journey. After emerging from solar conjunction in November, when Earth's view is no longer blocked by the sun's glare, 3IATLAS will pass through a region of space that offers gravitational leverage points for reaching Earth, Venus, or Mercury with minimal additional velocity change. The November 21st to December 5th window that Dr. Loeb identified in his public statements isn't arbitrary selection or convenient approximation. It's when the object's position relative to Earth creates optimal transfer orbits for any deployed probes. When Hohmann transfer trajectories and their more efficient variants allow maximum payload delivery to Earth vicinity with minimum energy expenditure. A few meters per second of delta applied at the right moment during this window could send a small probe, perhaps no larger than a washing machine or even a smartphone, on a direct intercept course with Earth that arrives weeks or months later. Backward trajectory analysis, running the orbital mechanics in reverse to see where 3IATLAS came from rather than where it's going, reveals another anomaly that bothers astronomers who've examined the data carefully. The path this object took to reach our solar system appears to have included close passes to at least 3 other star systems over the past million years, if you extrapolate backwards using current velocity and direction. Each encounter would have provided gravity assists that adjusted its course, bending the trajectory through gravitational interactions with those stellar systems. The cumulative effect of these encounters should have randomized its approach angle to our solar system, introducing chaos into the path through repeated gravitational perturbations at each star it passed. Instead, it arrived with surgical precision, aligned with our ecliptic, timed with planetary positions. This suggests either incredible coincidence that stretches probability beyond breaking point, or active navigation during the interstellar journey, course corrections made between stellar encounters to maintain targeting on our solar system despite perturbations trying to deflect it. The Jupiter encounter, scheduled for March 2026, presents the most intriguing possibility for those monitoring this object's journey. At its closest approach, 3IATLAS will pass within range of the Juno spacecraft's instruments currently orbiting the gas giant, providing opportunity for close-range observation from assets we already have positioned. But, more importantly, from dynamics perspective, Jupiter's massive gravity well could dramatically alter the object's trajectory depending on exact approach, geometry, and velocity. Depending on the precise flyby parameters, that tiny differences in position or speed would determine, 3IATLAS could gain enough velocity to escape our solar system entirely at much higher speed than it arrived. Or it could lose enough velocity to become gravitationally bound to our Sun, captured into an elliptical orbit that would bring it back through the inner system repeatedly over thousands or millions of years. The choice of which outcome occurs might not be left to chance if this object can navigate, if it can make the tiny velocity adjustments that would steer it toward capture or escape according to mission parameters we can't access. Orbital mechanicists working in universities and space agencies have run thousands of simulations trying to find natural explanations for 3IATLAS's observed path. They've modeled different origin points, various ages for the object's journey through space, multiple stellar encounter scenarios that might explain its current trajectory. None produced the observed path with probability that lets you comfortably invoke chance as explanation. The best fit models, the simulations that come closest to matching what we actually see, require assuming 3IATLAS originated from a specific point in space at a specific time, with a specific velocity vector, as if launched rather than naturally ejected by stellar evolution or planetary formation processes, as if someone or something aimed this object at our solar system billions of years ago and set it on a path that, with occasional corrections to account for gravitational perturbations, would arrive exactly when and how we're observing it arrive now. Something unprecedented has been happening in the normally transparent world of astronomical observation, a pattern of information control that extends across agencies, nations, and institutions in ways that suggest coordination rather than coincidence. Data about 3IATLAS is being filtered, delayed, and possibly suppressed according to timelines that don't match normal scientific publication processes. The patterns are too consistent across multiple space agencies operating under different governments with different funding structures and accountability mechanisms to result from independent technical failures or bureaucratic delays. We're witnessing either the most remarkable series of unfortunate mishaps in modern space science history, or a coordinated effort to manage information about our interstellar visitor until decisions are made about what the public should know and when they should know it. The timeline of silence begins with China's Tianwen-1 mission orbiting Mars with cameras and spectrometers that had perfect viewing geometry for 3IATLAS during the October flyby. Despite being positioned to capture potentially historic images of an interstellar object passing closer to Mars than any confirmed visitor has approached any planet during our observation period, the China National Space Administration has released nothing. Not a single image, not a press release, not even an acknowledgement that observations were attempted or data was collected. This from an agency that typically celebrates every achievement of their Mars program with extensive media coverage, press conferences, detailed technical reports. The silence is completely out of character, suggesting either technical failure so embarrassing they won't acknowledge it, or successful observations of something they've decided not to share. Russia's contribution to the ExoMars mission includes sophisticated spectrometers capable of detailed compositional analysis that should have gathered valuable data about 3IATLAS's chemistry during close approach. The Russian Academy of Sciences, normally eager to share scientific discoveries that enhance their prestige in international community, has published nothing about these observations. Individual researchers who were vocal about 3IATLAS in July and August, when the object was first detected, posting excited commentary on social media and professional forums, have gone quiet, their accounts dormant, research pages not updated. It's as if the entire Russian space science community has collectively decided this particular interstellar object isn't worth discussing publicly, a unified silence that coordination, rather than coincidence, seems to explain better. The Japanese Space Agency, JAXA, has monitoring equipment on the International Space Station that could track 3IATLAS from low Earth orbit, free from atmospheric distortion that limits ground-based observations. They have said nothing publicly. The Indian Space Research Organization, which still has a functioning orbiter around Mars years past its original mission lifetime, maintains complete silence about whether their instruments were directed toward this visitor. Even the European Southern Observatory, with its powerful ground-based telescopes in Chile, normally prolific in releasing observations of interesting astronomical phenomena, has been unusually reticent about follow-up observations and spectroscopic analysis. The pattern extends across every major spacefaring nation and significant astronomical institution. A coordinated quiet that whispers louder than any official statement could. Private communications between researchers paint a disturbing picture according to leaked messages that have appeared on platforms like WikiLeaks and encrypted channels used by whistleblowers. These messages suggest that preliminary findings about 3IATLAS were so anomalous, so far outside expected parameters for natural objects, that multiple space agencies agreed to a voluntary embargo on publication until further analysis could be completed and coordination established about how to present findings. The key phrase that appears repeatedly in these leaked communications is pending verification of extraordinary claims. The scientific principle that extraordinary claims require extraordinary evidence is being invoked to justify unprecedented information control, delaying release of data that would normally flow freely through preprint servers and conference presentations within days or weeks of collection. Academic preprint servers tell their own story through absence rather than presence. Since October 3rd, when the Mars encounter occurred, not a single paper about 3IATLAS has appeared on RxCV, the primary repository for astronomical research, where scientists share findings before formal peer review and journal publication. This, despite dozens of teams conducting observations, analyzing data, presumably drawing conclusions from what their instruments recorded. Statistical analysis shows this silence is essentially impossible under normal circumstances where researchers compete to publish interesting findings first, building reputations through timely disclosure of discoveries. For comparison, the previous interstellar object, Borisov, generated over 30 preprints in its first month of intensive observation as teams rushed to characterize this rare visitor. 3IATLAS has produced 0 papers in the weeks following its most significant encounter with Mars, a statistical outlier so extreme it demands explanation beyond normal publication timelines. Freedom of information. ACT requests filed with NASA have been met with unusual responses that deviate from standard protocols. Instead of the typical denial citing exemptions for preliminary scientific data or partial release with redactions, the agency has invoked rarely used national security exemptions. The claim that observations of what's officially characterized as a comet could impact national security has raised eyebrows among transparency advocates and sparked lawsuits. The Electronic Frontier Foundation has filed emergency motions demanding release, arguing that the public has a right to know about potential extraterrestrial contact if that's what these observations suggest. The legal battles are ongoing, playing out in federal courts, while the object continues its journey and opportunities for observation pass irretrievably. Meanwhile, the disinformation campaign, or what appears to be systematic suppression, has intensified across digital platforms. Social media companies have begun flagging posts about 3IATLAS as potential misinformation, even when they simply quote published scientific papers or share publicly available images. The algorithmic flagging seems indiscriminate, catching genuine scientific discussion alongside wild speculation. Search engines have adjusted their algorithms in ways that deprioritize 3IATLAS content, pushing down search results so official NASA pages that haven't been updated since before the Mars encounter appear at the top, while more recent analysis from independent researchers gets buried pages deep where most users never look. The digital landscape is being shaped, perhaps deliberately, or perhaps through automated content moderation systems, responding to mass reporting, to minimize public awareness and discussion of our interstellar visitor. The amateur astronomy community has become the primary source of real information, filling the void left by institutional silence. But they're facing unprecedented challenges that seem designed to frustrate independent observation. Several prominent amateur astronomers have reported equipment failures at critical moments when they were attempting to track or image 3IATLAS. Telescopes that were functioning perfectly suddenly lose alignment, requiring time-consuming recalibration that causes them to miss observation windows. Computer systems controlling automated tracking have crashed, destroying hours of carefully accumulated data. Camera sensors have developed anomalies just as the object passes through their fields of view. While equipment failures happen in any technical endeavor, the clustering around 3IATLAS observations is statistically improbable enough to raise questions about whether some failures might not be entirely accidental. Government involvement extends beyond civilian space agencies into military and intelligence domains that normally operate far from public astronomy. The United States Space Force has activated tracking assets normally reserved for monitoring adversarial satellites and potential weapons in orbit, directing these classified systems toward 3IATLAS, according to sources within defense contractor community. The National Reconnaissance Office, America's spy satellite agency, has reportedly retasked imaging satellites with capabilities that exceed anything publicly acknowledged to observe this interstellar visitor. The involvement of military and intelligence assets in studying what's supposedly a natural comet raises obvious questions about what classified analysis has concluded that civilian agencies either don't know or aren't sharing. When spy satellites start watching comets, you have to wonder what they're really looking for, or what they've already found. International cooperation has taken strange forms that suggest crisis management rather than normal scientific collaboration. The United Nations Office for Outer Space Affairs convened an emergency session in late October that was closed to press and public, requiring attendees to surrender electronic devices and sign non-disclosure agreements more stringent than typical diplomatic protocols. The few leaked details suggest discussions of protocols for potential contact scenarios, coordination of public messaging to prevent panic, and frameworks for decision-making about response options. If 3IATLAS proves to be artificial, or if contact is initiated. Why would a natural comet require UN-level involvement in information management and emergency planning? The very fact of these meetings suggests official assessment has concluded possibilities that public statements carefully avoid acknowledging. Financial markets have begun showing unusual patterns that correlate with 3IATLAS's approach, and apparent information about it flowing through classified channels. Aerospace and defense contractors have seen unexplained stock movements, trading volumes, and price changes that don't correspond to any announced contracts or public news. Companies specializing in deep space communication equipment have received large unattributed orders according to supply chain sources, purchases that don't align with any publicly disclosed missions or projects. The derivatives market shows betting patterns consistent with insider knowledge of significant announcements expected in November or December, options positions that would profit enormously if certain revelations occurred. Someone with deep pockets and access to information not available publicly is positioning for a revelation, preparing to profit from or hedge against whatever they believe is coming when 3IATLAS reemerges from solar conjunction and observations resume. The most disturbing evidence comes from whistleblowers within the space agencies themselves, individuals risking careers and potentially facing legal consequences for speaking about what they've seen or been told in internal meetings. Anonymous sources describe heated internal debates about public disclosure protocols. Some argue for full transparency, insisting that humanity has a right to know if we're encountering potential evidence of extraterrestrial intelligence or technology. Others insist the public isn't ready for such revelations, that premature disclosure would trigger panic, economic disruption, social unrest that could destabilize institutions already strained by recent crises. The compromised position that appears to have emerged from these debates is gradual revelation, releasing information in controlled doses designed to prepare collective consciousness while preventing catastrophic reaction, allowing people to adjust their worldviews incrementally rather than having them shattered by sudden confirmation of realities they weren't psychologically prepared to accept. What happens in December will clarify much, but resolve little if patterns continue. When 3IATLAS reemerges from behind the sun, when it becomes observable again from Earth-based instruments and spacecraft positioned throughout our solar system, we'll see whether agencies and institutions withholding information now release it then, whether explanations are offered that address anomalies comprehensively, whether the public is brought meaningfully into the conversation or kept at arm's length while experts debate behind closed doors. If transparency returns, if we receive detailed imagery and honest assessments of what 3IATLAS is and what it means for humanity's place in cosmos, then the delays can be attributed to normal processes, however frustrating. Institutions move slowly. Analysis takes time. Caution with extraordinary claims is appropriate even if inconvenient for those eager for answers. But if the silence continues through December and beyond, if data remains classified or embargoed indefinitely, if only sanitized summaries are released, while critical details stay hidden behind national security classifications, then questions about institutional agendas and manufactured crises become harder to dismiss as paranoia. Then we're forced to consider that information control isn't about protecting scientific integrity or ensuring accuracy before publication, but about managing public consciousness, about deciding for billions of people what they should know about their universe and when they should be permitted to know it. December will reveal not just whether 3IATLAS is natural or artificial, passive or active, but whether the systems we've built for collective decision-making can handle truths that challenge fundamental assumptions about human uniqueness and cosmic isolation. The deep state scenario, as researchers and critics articulate it, suggests 3IATLAS is being positioned as a potential manufactured crisis regardless of what it actually is. A convenient external threat that could justify extraordinary measures that populations might otherwise resist. Global surveillance expansion justified by need to monitor for alien probes. Resource nationalization explained by necessity of preparing for contact or conflict. Restrictions on civilian space activities rationalized through planetary defense concerns. The consolidation of power under emergency protocols that never quite end because the cosmic threat, real or exaggerated, persists indefinitely. This playbook isn't new or theoretical. Governments throughout history have used external threats, whether genuine foreign adversaries or manufactured enemies, to expand authority and constrain freedoms that peacetime wouldn't permit limiting. The question isn't whether governments use crises to expand power. Historical record proves they do. But whether 3IATLAS represents such an opportunity being deliberately exploited, and whether elements within government and intelligence communities are preparing responses that serve interests having little to do with planetary protection or scientific discovery. The timing of certain events supports suspicion without proving conspiracy. President Biden's August executive order redesignating NASA as a national intelligence and security agency came months before the Mars encounter, but after 3IATLAS's detection. The practical effect is that NASA's data and operations now fall under national security classification protocols, allowing information about what NASA observes to be withheld from public indefinitely under national security justifications that can't be challenged without security clearances most researchers don't possess. The government shutdown that began October 1st, furloughing 15,000 NASA employees just as preparation for Mars observation should have been intensifying, creates perfect cover for information management. With public-facing operations disrupted and communication offices unstaffed, whatever was observed during the Mars encounter could be processed and analyzed through classified channels without normal scrutiny from scientific community or press. The shutdown's official cause, congressional deadlock over healthcare subsidies and tax policy, seems almost comically mundane compared to its convenient timing. Whether that timing is genuine coincidence or calculated coordination depends on whether you believe government agencies are capable of such manipulation, and what evidence you weight most heavily in making that assessment. Then there's the Quantico meeting on September 30th, the day before the shutdown began. Over 800 flag officers, generals, and admirals from all branches of the U.S. military were summoned to Quantico Marine Corps Base for what was officially described as a routine briefing. 800 flag officers don't assemble for routine anything. These are the decision makers, the strategic planners, the people who would need coordination if a crisis response was being prepared or if contingencies for unprecedented scenarios required military involvement. What were they briefed about? Official channels remained silent, but the timing, one day before NASA goes dark and 2 days before 3IATLAS reaches Mars, suggests the briefing concerned the object, possibly intelligence assessments about its nature, possibly military contingencies if it proves hostile, possibly coordination protocols for managing public reaction if observations reveal something that can't be easily explained away. The insurance industry's silence on cosmic threat implications becomes particularly telling when you consider their business model requires pricing and preparing for low-probability, high-consequence events. Insurance companies employ armies of actuaries whose entire profession involves modeling risk and determining what premiums should be charged for various coverage types. They assess hurricanes, earthquakes, pandemics, solar flares, anything that could cause widespread damage requiring payout of claims. They've even begun factoring climate change into long-term models, as evidence mounted that extreme weather events are increasing in frequency and severity. Yet 3IATLAS, an object that a Harvard astrophysicist publicly ranks as having 40% chance of technological origin, an object whose trajectory some researchers suggest could allow deployment of Earth-bound probes, has generated zero public response from the insurance sector according to available records. No white papers discussing cosmic threat exposure, no risk assessments calculating probabilities of various contact scenarios, no premium adjustments for policies covering damage from extraterrestrial objects or events. This silence could mean insurance actuaries have assessed 3IATLAS as negligible risk, just another comet posing no realistic threat to insured assets or lives. Or it could mean they've been advised quietly through channels that don't leave paper trails, through phone calls and private meetings that never get recorded in official minutes, that discussing 3IATLAS publicly isn't in anyone's interest, that raising the topic might create panic, trigger market instability, cause economic disruption that dwarfs any actual physical threat the object might pose. Keep it quiet. Keep it controlled. Let the public believe it's just another space rock until circumstances force acknowledgement of realities that can't be hidden any longer. This is where manufactured crisis theories gain traction among researchers examining patterns rather than isolated events. If you wanted to stage, not an alien invasion exactly, that's too crude, but a perceived extraterrestrial presence that could be spun toward various political objectives. How would you orchestrate it? You'd need a plausible threat or opportunity, something ambiguous enough that you could interpret it multiple ways, depending on what narrative serves your purposes at any given moment. 3IATLAS, with its genuine anomalies and scientific uncertainties, fits perfectly, neither definitely natural nor definitely artificial, but hovering in between, where interpretation becomes political rather than purely scientific. You'd need control over information channels, ensuring that only approved narratives reach mass audiences while alternative interpretations get suppressed or marginalized. The NASA reclassification and institutional silence accomplish that effectively. You'd need military readiness without creating public alarm that might trigger questions about what threats are being prepared against. The Quantico briefing and Space Force involvement check that requirement. Mobilization disguised as routine exercises and orbital monitoring, presented as normal space situational awareness rather than preparation for potential conflict or contact. And you'd need mechanisms for implementing emergency powers quickly if circumstances required rapid action. Frameworks for lockdowns, movement restrictions, resource controls that could be activated under crisis justification. Executive orders granting such authority already exist, drafted after September 11th and updated periodically, waiting to be invoked when events or manufactured narratives justify their use. 3I/Atlas provides plausible trigger for activating authorities that peacetime would never permit deploying. The cost of being wrong in either direction creates impossible risk calculation that paralyzes institutional response. If 3IATLAS is genuinely artificial and potentially threatening, and we dismiss it as natural comet, we're unprepared when capabilities or intentions reveal themselves in ways that don't allow time for reactive scrambling. The cost of that error could be catastrophic, ranging from missed opportunities for beneficial contact to inadequate defenses against hostile actions. We didn't take seriously until too late. But if 3IATLAS is natural and we treat it as artificial threat, we waste resources on unnecessary preparations, damage scientific credibility through false alarms that undermine future warnings, and potentially create public panic or cynicism that makes rational response to actual threats more difficult when they eventually emerge. Governments and institutions operate on risk calculations where visible action proving unnecessary damages careers and budgets more severely than invisible inaction, failing to prevent unforeseeable catastrophe. No one gets blamed for failing to prevent what couldn't reasonably be anticipated, but everyone gets blamed for crying wolf about threats that never materialize. December approaches as the window when 3IATLAS will re-emerge from behind the sun, becoming visible again to Earth-based observers after weeks hidden in solar glare during what should have been its period of maximum activity. The perihelion passage on October 29th, when the object swung closest to our star at approximately 1.36 astronomical units, occurred completely hidden from our direct observation. We have no images from that critical window, only sparse data from Mars orbiters in early October, and whatever classified observations might exist from solar monitoring satellites that haven't shared their findings publicly. What we do know is that 3IATLAS survived perihelion intact. Objects approaching the Sun sometimes fragment from thermal stress, breaking apart spectacularly as ices sublimate faster than structural integrity can withstand. The fact that this visitor remains coherent, still following its calculated trajectory outward toward the outer solar system, is evidence for something, though interpreting what requires more data than current limited observations provide. The European Space Agency's JUICE spacecraft, Jupiter Icy Moons Explorer, is positioned to observe 3IATLAS during November as it travels toward its own destination in the Jovian system years from now. JUICE carries sophisticated instruments, including cameras, spectrometers, and particle detectors that could provide unprecedented detail about the object's composition, structure, and emissions. If observations proceed as planned, ESA has confirmed JUICE will attempt observations, potentially coordinating with NASA's Europa Clipper mission, also en route to Jupiter. The twin ultraviolet spectrographs on both spacecraft could observe 3IATLAS simultaneously from different angles, providing stereoscopic data that reveals three-dimensional structure and rotation characteristics invisible to single-point observations. This is the kind of detailed measurement that could finally resolve whether we're looking at irregular natural object or something with geometric regularities that nature wouldn't produce without assistance. But there's a significant catch that frustrates those eager for answers. JUICE is currently close to the Sun in its orbital trajectory, using its main high-gain antenna as a heat shield to protect sensitive instruments from solar radiation. It's communicating with Earth through a smaller medium-gain antenna at much reduced data rate, limiting how much information can be transmitted during any given communications window. And because JUICE sits on the opposite side of the Sun from Earth during this period, transmission distances are at maximum and relay opportunities are limited by orbital geometry. ESA has stated clearly, managing expectations in official communications, that they don't expect to receive data from JUICE's 3IATLAS observations until February 2026, 3 full months after the observations occur. By then, the object will have continued its outward journey past Earth's orbit, approaching Jupiter for its March encounter, and whatever it did or didn't do during December will already be history recorded but not yet analyzed. This delay is frustrating but unavoidable given the realities of orbital mechanics and telecommunications bandwidth across astronomical distances. It also means that if something significant happens in December, if 3IATLAS releases smaller objects as remote viewers predicted, if it transmits signals or alters course or exhibits behaviors requiring immediate response, we'll be reacting without benefit of the best observational data that JUICE could provide. We'll have ground-based telescope observations, valuable but limited by atmospheric distortion and the object's relatively faint magnitude as it recedes from the Sun. We'll have space telescope observations from Hubble and Webb if those assets are directed toward 3IATLAS, but scheduling those observations requires months of advanced planning and competing against countless other astronomical programs demanding time on humanity's most capable instruments. Amateur astronomers will be absolutely critical in December, filling gaps that professional coverage leaves through the distributed network of private telescopes operated by passionate individuals rather than large institutions. The global community of amateur observers, coordinated through online platforms and driven by genuine curiosity, rather than institutional constraints or funding cycles, can provide near-continuous monitoring as 3IATLAS becomes visible again. They've already captured images during the object's approach that revealed details professional astronomers missed, working with modest equipment, but extraordinary dedication and processing skills that extract maximum information from limited photons. Their contributions will only increase in importance as professional assets remain focused on other targets or remain tangled in bureaucratic delays that prevent rapid response to unexpected developments. One particular amateur, a YouTuber known as Dobsonian Power for the type of telescope used, captured images during the Mars flyby period that sparked intense online debate lasting days. The images, enhanced through stacking multiple exposures to increase signal-to-noise ratio and pulling out faint details invisible to single frames, appeared to show angular structures within 3IATLAS's coma, the cloud of gas and dust surrounding whatever nucleus lies beneath. Dark features that didn't match the diffuse symmetric distribution expected from simple sublimation of ices. The structures looked geometric to some observers, almost artificial, leading to wild speculation about internal machinery or surface installations visible through surrounding material. Critics argued vigorously that the features were artifacts of image processing, pareidolia, where human pattern recognition sees faces and structures in random noise that actually contains no meaningful information. But the debate itself highlights how starved we are for clear, unambiguous data, how much interpretation is required when dealing with fuzzy images of an object millions of miles away that we can barely resolve even with our best instruments. The prophecies and remote viewing sessions that placed special emphasis on December take on different character as the month approaches. Whether those predictions were accessing genuine information about future events through mechanisms we don't understand, or whether they reflect psychological patterns and cultural expectations projected onto an ambiguous situation, we'll have opportunity to test them against observable reality. If December brings nothing unusual, if 3I-ATLAS simply continues outward as any comet would after perihelion passage, gradually fading as distance from the sun increases and activity diminishes predictably, then the remote viewers were wrong, and the prophecies were products of imagination rather than precognition. The object will join Oumuamua and Borisov as confirmed interstellar visitors. Weird, perhaps, but ultimately natural, explainable through exotic chemistry and unusual origins, but not requiring us to invoke intelligence or technology. But if December brings anything unexpected, any releases of smaller objects, any signals detected by radio telescopes, any maneuvers that can't be attributed to outgassing or gravitational perturbations, then every prediction gains credibility retrospectively, and every dismissal looks premature. Then we're forced to take seriously testimonies we might have preferred to ignore, to consider possibilities that comfortable worldviews struggle accommodating. The convergence of multiple independent sources, scientific observations showing genuine anomalies, remote viewers describing technological features, prophetic traditions identifying December as a critical juncture, all pointing toward the same general conclusion that something significant is happening or about to happen, becomes harder to dismiss as mere coincidence or collective delusion when physical observations confirm at least some predictions. As you drift toward sleep or continue listening through the hours of darkness, let these questions settle into consciousness without demanding immediate answers. 3I-ATLAS represents more than astronomical curiosity or scientific puzzle. It's a mirror reflecting humanity's readiness or unreadiness for truths that might be approaching whether we're prepared or not. The object itself, whatever it actually is, beneath layers of ambiguity and competing interpretation, doesn't care about our beliefs or institutional responses. It follows physics, executing whatever mission parameters were encoded billions of years ago, if it's artificial or simply obeying gravitational mechanics and thermodynamics if it's natural. The universe proceeds indifferently to our hopes and fears, our models and assumptions, our readiness or resistance. What matters is how we respond to uncertainty, how we handle evidence that doesn't fit cleanly into expected categories, how we balance skepticism that prevents premature conclusions against openness that allows genuine discovery. The remote viewers might have perceived something real about 3I-ATLAS, accessing information through consciousness in ways our materialist models don't accommodate. Or they might have perceived only their own expectations and cultural narratives, producing convergent testimonies through contamination rather than observation. The scientific anomalies might indicate artificial construction, technologies from civilizations that achieved spaceflight before Earth formed. Or they might reflect natural processes operating under conditions we haven't encountered before in our limited exploration of cosmic diversity. December will clarify some uncertainties while introducing others. We'll have more data, better observations, higher resolution images that resolve features currently blurred by distance and atmospheric seeing. But more information doesn't always produce clearer conclusions. Sometimes additional data reveals new anomalies, raises fresh questions, pushes definitive answers further into the future, as each revelation demands additional investigation. The trajectory of 3IATLAS through our solar system, whether guided by ancient intelligence or shaped purely by gravitational mechanics, offers opportunity for humanity to practice holding ambiguity, to sit with not knowing, to resist the premature closure that chooses comfortable wrong answers over uncomfortable uncertainty. Perhaps the greatest gift this interstellar visitor offers isn't resolution of whether we're alone in the universe, but demonstration of how we think about such questions, how institutions and individuals respond when reality refuses to conform to established categories. We're learning about ourselves through our varied reactions to 3IATLAS, about our capacity for wonder and our resistance to transformation, about our hunger for a connection with cosmic intelligence and our fear of what such connection might mean for comfortable illusions about human centrality and control. The object will pass through and eventually exit our solar system, either this year on its current hyperbolic trajectory or centuries from now if Jupiter's gravity captures it into bound orbit. But the questions it raises, the possibilities it forces us to consider, those will remain long after the visitor itself has departed, seeds planted in human consciousness that will grow in unpredictable directions as we continue our stumbling journey toward cosmic maturity. Sleep well, if sleep comes, or rest in the mystery if wakefulness persists. The universe is vast and patient and full of wonders we're only beginning to glimpse. 3IATLAS is merely one message, or among countless others we haven't yet learned to recognize, one question in an infinite dialogue between matter and consciousness, cosmos and comprehension. Whatever December reveals or conceals, the conversation continues. Our participation in that dialogue, our willingness to ask better questions even when answers remain elusive, might be what matters most in the end.